Hey everyone, in this video I'm going to show you how to solve the ALEKS problem called Understanding Melting Point Trends of Fatty Acids. This problem is going to give us the structures of 4 fatty acids, and our job is to rank those 4 fatty acids by increasing melting point. Now to do this, there are 2 variables that we're going to take into consideration. One of the things that we're going to consider is the structure of the carbon chain of the fatty acid, this portion of the fatty acid out here. If that carbon chain is just a straight alkane, all carbon-carbon single bonds, no double bonds at all, that molecule is going to tend to have a higher melting point than one that has a trans double bond. And if we have a molecule that has a cis double bond present, that molecule is going to typically have the lower melting point. So this is, again, one of the things that we're going to take into consideration when we're ranking these molecules. It's not the only variable that we are going to take into consideration, and that might be obvious when you're looking at this problem right here, because you can see that we have 2 molecules that have trans double bonds, and we have 2 molecules that have cis double bonds. So we have to have a way of distinguishing these 2 molecules from each other and distinguishing those 2 molecules from each other. So the other variable that we're going to consider is the number of carbon atoms. The more carbon atoms a molecule has, the higher its melting point is. I'm going to add melting point to both of this. Okay, so looking at these 4 molecules all together, the first thing that we're going to do is focus on these 2 molecules because they both have the trans double bond, which means that these 2 molecules are going to have a higher melting point than either of the cis, right? So one of these is going to be the highest melting point and the other one is going to be the second highest. And the way that we differentiate between them is just simply by counting the number of carbon atoms. This first molecule that I'm focusing on has 2, 4, 6, 8, 10, 12, 14, 16 carbons, and this one has 2, 4, 6, 8, 10, 12, 14, 16, 18 carbons. So this one with 18 carbons and the trans double bond is going to be our highest, and I want to say ALEKS is using number 4 for the highest in this problem. And then our this molecule that has trans double bond, and if I remember correctly, we said 16 carbons here. This one is going to have the second highest melting point. Now of the other 2, so this one and this one, they both have the cis double bonds, which means that they are on the lower end of things. And to differentiate between them, again, we're going to count their carbon atoms. 2, 4, 6, 8, 10, 12, 14, 16 versus 2, 4, 6, 8, 10, 12, 14. So this is a cis double bond and 16 carbons. This is a cis double bond and 14 carbons. The cis double bond with the smallest number of carbons is going to be our lowest melting point. The other will be number 2. Let's keep practicing this. I'm going to see if I can take this and copy it and use it on the next problem. Oh, I already have it written down on the next problem. Okay, so for this one, every once in a while, ALEKS is going to use condensed notation, and sometimes it uses both condensed and line notation in the same problem. That's okay. One of the challenges with the condensed notation is that we can't tell by looking at the double bonds if they are supposed to be cis or trans, at least not the way ALEKS is representing them, but that's going to be okay in this problem. It's going to work out to be all right. So this molecule right here, let's just count up carbons. This molecule has 18 carbons. The next one has 16 carbons, and I'm doing that just by 16 plus 2, 14 plus 2. This first molecule has 1 plus 7 is 8, 9, 10, 11, 12, 13, 14 carbons. And the one at the bottom has 8, 9, 10, 15, 16 carbons. These 2 molecules right here have no carbon-carbon double bonds in them at all. So they are higher melting points than the molecules that have the carbon-carbon double bonds. The one that, of these 2, the one that has the most carbons is going to be our highest melting point, which is number 4. And then this one is going to be our next highest, number 3. These two with the double bonds, 16 carbons, is going to be our number 2, and the one that has the smallest number of carbons and the double bond, that's going to be our lowest. Let's look at one more example just so you get plenty of practice. Here is one where we're mixing line notation with condensed notation. These two are saturated, no double bonds, so these two molecules right here will have the highest melting points. And then, melting points, and these two with their double bonds, they will have the next highest. Let's count up our carbons. Down here we have 22 carbons and 20 carbons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 carbons. And our first molecule, 2, 4, 6, 8, 10, 12, 14, 16, 18 carbons. So we're looking at the highest number of carbon atoms and no double bonds. That is going to be our highest melting point, number 4. We have 2 molecules with 20 carbon atoms, so it's a tie in terms of the number of carbon atoms. This molecule has no double bond, so that's going to be our next highest melting point. This will be number 2. And our lowest melting point will be the smallest number of carbon atoms with the double bond. Hopefully that helps you get through this problem. Good luck.